A common energy source for microgrids is wind power. To be able to cover flexible loads with wind turbines, they are often combined with batteries. In this video, I show how you can plan and simulate microgrid with wind turbines and batteries using nPro. Hi and welcome to this nPro tutorial. I'm Marco, and in this video we will go step by step through the dimensioning process of a microgrid with wind turbine and battery. Let's dive into it and see how that works in nPro.
On the start page of the tool, I can click on Energy Hub, then on Create a new project and select a project template. It's not really important what you select here because you can modify the system afterwards as you want. I add the electricity demand, I add the battery and a connection to the electricity grid. I deactivate the photovoltaic and the hydrogen technologies. I will now change the parameters of the battery in order to make sure that the optimization will actually install a battery. So I increase the lifetime. I set the maintenance to 0. Then we take the example demands of nPro. For this example, I increase the electricity price and I will decrease the feed-in tariff. That just leads to a system that really uses the battery, or where the battery is actually installed. We will see this now. The optimization says, yes, I want a battery, and it's 1370 kilowatt hours of capacity. It has 200 full charging cycles over the year, and the full wind power capacity is installed. We could now modify the capacity of the battery if we want to do that. I will do that now to change it to 1500 kilowatt hours and then click on Simulate System Operation. And then we will have an overview how the dispatch looks like. Here we see that the wind power covers most of the electricity demand. If we go with the mouse over the lines, we can also see the quantity. Then on the bottom, we can visualize the operation of the systems. Here, for example, the heat map plot, so the hours of the day against the days of the year. For the electricity generation, we see windy days and not so windy days, especially in summer. We can also visualize the battery, the state of charge of the battery. And here we see that in many cases, the battery is charged in the afternoon hours with wind power and then discharged over the evening and night. And because we have a peak demand in the early morning hours, the battery is then used to cover the peak demand and supports the wind turbines. The energy demand can also be visualized. This is electricity demand, and here we see that there at 8 o'clock there's the increase of the electricity demand. We can also have a look at the summary of the results. Here, for example, electricity generation and import. We see that about 90% of the electricity is generated by the wind turbines and only 10% is imported. We have an overview of the emissions and the primary energy factors, or the primary energy. The factors of the emissions and the primary energy factors can be adjusted in the settings of the optimization. Then let's have a look at the economic results. In this case, we see that the revenues are higher than the costs, so the system is profitable. We have a cash flow table here, and you can see that after 20 years, the net present value is positive. The visualization of the net present value over the years. We have costs regarding the energy supply or the energy imports, operation costs, and we have the revenue streams, which are very important to decide if the system is profitable or not. So the system operator of this microgrid would get revenue for every kilowatt hour that is covered for the electricity demand, and we can change this here. Let's put it to 10 cents per kilowatt hour, and if we scroll up, then we see now the system is not profitable anymore. The net present value is negative, and I could now just go up in 1 cent per kilowatt hour steps. And then let's have a look how the cash flow changes. That would be cash revenue where the system is just going into the positive direction, so where the net present value is positive after 20 years, and that would be the case for, in this case, 14 cents per kilowatt hour.
If you have any questions or remarks about this video, feel free to leave a comment. If the video was helpful for you, please give us a like and subscribe to our channel. Thank you for your interest and see you next time.